There is a secret place in the universe that only you can enter. Your mind is an impenetrable location, entirely locked away from everyone else. Inside this private space, we all experience reality differently. If I ask you to imagine an apple, you might see a crisp 3D model floating in a void, or you might see absolutely nothing at all, instead just feeling the abstract concept of an apple, or sitting in total silence. We all possess this highly complex inner world, yet from a purely biological standpoint, it is a mystery why nature bothered to build such an elaborate, energy-intensive space in the first place. To understand the architecture of your consciousness, we have to strip away all this human complexity. We need to go back and look at what life was like before the mind even existed. When single-celled life first emerged, it had absolutely no inner space or thought process. These early organisms operated like biological robots, trapped in inflexible loops of automated reflexes. If a cell sensed food, that chemical signal triggered an immediate, uncontrollable physical reaction to move toward it. This diagram shows how direct automation works. A signal travels along a direct, unbroken line from sensory input to physical output with zero delay. In a complex, unpredictable environment, this is a dangerous survival strategy. The organism cannot hesitate, evaluate threats, or change its direction. To survive, life needed a way to pause. The earliest version of a mind was an evolutionary waiting room, a literal delay engineered between sensing the world and moving the body, granting organisms the flexibility to evaluate their next move. We can see level 1 of the simulation engine in the roundworm, which operates on a tiny neural network of exactly 302 neurons. This tiny network creates a microgap. It allows the worm to hold a short-term memory of a negative stimulus, delaying its automated reflex just long enough to steer away from danger. Scaling up to level 2, we find the bee. Its neural network is upgraded to roughly 1 million neurons. This animated vector map shows how a bee uses this wider cognitive gap. Instead of pausing, it holds massive mental maps of the terrain, actively calculating geometric vectors between floral locations, the hive, and the shifting angle of the sun. At this stage of complexity, the biological gap operates as a full rendering engine, capable of simulating physical space. Level 3 introduces a completely different architecture. With about 500 million neurons, the octopus proves that biological software can evolve in bizarre, non-linear directions. Instead of keeping all those neurons in one centralized location, they use distributed processing. Each octopus arm houses a localized mini-mind, entirely capable of autonomous tasting, thinking, and acting on its own. The central brain does not dictate every movement. It acts as a high-level coordinator, letting the arms handle the local details. A mind does not have to be a single monolithic entity. Reality can be simulated and experienced as a sprawling, decentralized network. Birds represent level 4. Packing billions of neurons into very small spaces, species like the scrub jay expand their inner gap to simulate time and other players. Inside their minds, scrub jays track the passage of time. They actively render the decay rate of hidden food, knowing exactly when a buried worm has gone bad and when to switch to hunting for fresh nuts. This logic tree diagram shows their greatest cognitive leap. If a scrub jay observes a rival watching them hide a meal, their primary routine is actively interrupted and overridden. They simulate the potential thief's perspective and later alter their own behavior to re-hide the stash in secret. The mind has evolved beyond rendering simple geographic maps. It constructs a virtual replica of the world that includes the invisible intentions of adversaries. The human mind expands the scale of this gap significantly, running on a network of 86 billion neurons. Between 18 and 24 months, a toddler hits a crucial developmental milestone. Looking in a mirror, a baby suddenly realizes the reflection is itself, and that it is an entity capable of being observed by others. This diagram illustrates recursive simulation. We simulate minds simulating our minds. We think about what they think about us. These loops let you anticipate judgments. By viewing yourself through their eyes, you regulate your behavior to keep their goodwill, experienced as moral conscience. This shared pressure is what allows us to navigate massive societies of strangers. We aren't just following instincts. We are constantly calculating how to maintain the trust and cooperation of the group. Humans use this massive evolutionary gap to construct entirely fictional universes. Through storytelling, movies, and novels, we build worlds out of pure thought. Storytelling functions as a data transfer mechanism. It allows isolated minds to safely exchange complex concepts of morality, outlining exactly what we consider good and bad. Your most private thoughts and feelings have been heavily shaped by simulated events that never actually happened, yet feel entirely real to you. Your inner mind is a collaborative architecture. Every thought you have is shaped by the collective voices, stories, and perspectives of every human mind that lived before you.